All right, so this is part 2 of 18.3. We're on example 5, and we're looking at a pretty complicated triangle here. We have a little triangle right here, if you follow the arrows. We have a medium-sized triangle on the right side, if you follow the arrows. And then you have a completely full triangle, ABC. So we have triangle ABD, we have triangle BCD, and we have triangle ABC. So all of those triangles there are are all different, and they're going to have their own side measures. What we're asked to find is DC. So when you see that DC right there, I'll highlight it. Shouldn't highlight so large. Anyway, that's what we're asked to find right there. That's our unknown. All right. Now, how are we going to find that? Well, we do have a few things. We have this angle, we know is 28. If we're trying to find this, we need another side of the triangle BDC. This triangle right here, we need an angle and two sides, and we can use our trig knowledge to come up with our side that we're unknown here, the DC. Now, I would guess that we would need to find this side right there. If I have that side, then I can use the angle 28 degree angle and that known value, the height of the triangle right there, BD. And then this side, X, we can use those three items in a trig function in order to come up with that side DC. Now, I have a few other bits of information here, a little bit more help. I know this angle for the small triangle. If I'm dealing with it, I'm going to mark it red. I know this angle, 54 degrees, and I know this side, which is the hypotenuse of the red triangle, is 20. And if I'm looking for Y, that is actually opposite. It's an opposite side to that angle that is 54 degrees. So I have an angle that's 54 degrees. I am looking for the opposite side, and I have the hypotenuse of that triangle. If you're looking just at the little red triangle. So red triangle first. Okay, opposite and hypotenuse. I need the opposite side. I have the hypotenuse for that angle that's 54 degrees. OH is SOHCAHTOA, sine. It's a sine. So I've labeled my sides O and H. I figured out my trig function sine on the initial triangle that will help me get the information to solve the second triangle for that side I want, that I've been asked to solve for. So sine. Sine, what follows a sine? The angle 54 degrees, and that's equal to Y over 20. So the hypotenuse is 20. So I've set myself up an equation that I can use. I can multiply by 20, and solve for that, and I get Y is 20 sine 54. Okay? So with that, I can put in the calculator, so 20 sine 54, and that is 16.18, approximately. All right, 16.18. Now I can set up a second function. I'm going to use a different color with this angle that's 28. Maybe I'll use green since it's already green. So 28, and here I have the opposite side again is 16.18, and then I'm looking for the adjacent side that runs right into the angle. On the green triangle, we have nothing to do with the hypotenuse. So what we have is O and A, which is tangent. TOA, tangent. So tangent of the angle 28 is equal to opposite, which is 16.18 over adjacent, which is X. So X is on the denominator. When X is on the denominator, we switch those to solve. X is, we leave the 16.18 alone and replace X on the bottom with tangent 28 degrees. All right, so tangent 28 degrees is on the bottom. So if I just take that number that's already in my calculator, that's going to have at least 6 decimal places, and that will be more accurate than just typing in 16.18, would be a little less accurate. So I'm just going to leave it and hit divide, tangent 28, and that is 30.43. So approximately 30.43. So I would say that DC is approximately 30.43 units, whatever the units are. All right? Okay, so that's how you would find DC. Next one, it says, an airplane climbs at an angle of 12 degrees with the ground. Okay, find the horizontal distance it has traveled once it has reached an altitude of 500 feet. All right, now this is a great opportunity to see an application problem for this trig. They use trigonometry all the time in flight. So we have an airplane here, and don't laugh at my airplane. It's leaving the ground, and its flight path climbs at an angle of 12 degrees. Now, this is a talent all in of itself, not a talent really, but drawing the picture is very imperative so that you can see which the sides are and figure out where the angle is. You have to have a picture. So the first thing I would do is diagram what you read. So when it says an airplane climbs at an angle of 12 degrees, then you have your little airplane climbing. We have a horizontal, this is the ground here, and it's climbing at a 12-degree angle. Okay. Now the horizontal distance is along the ground. Okay, horizontal distance. I'm going to just write that out so that you see it. And we want to see what that is. We want to know what that is. Once the airplane has reached an altitude of 500 feet. Now this is your altitude. Okay, your altitude is how high the plane is, and that we want to be 500 feet. So we have a horizontal distance, we have an altitude, we have an angle for which it's flying. All right? So they have to figure that out. Pilots have to say, well, they have to know, okay, so once I get off the ground, I need to ascend at a 12-degree angle, and you need to have that much horizontal distance by the time you need to have 500 feet of clearance vertically after you've traveled so far. And they have this all figured out at airports all around the world so that they know exactly what is necessary so that the airplanes don't crash into things. But 500 feet altitude. So what we have here is our opposite side. Right here is the altitude, and we have an adjacent side that is a horizontal distance. Again, what we're not using here is our hypotenuse. Now, this is very typical. It doesn't always happen that way, but usually when we're dealing with real life scenarios, tangent is very popular for that type of function for many reasons, especially when we look at graphs. But it's very, very popular when we have real world application problems. So we're going to use tangent because we have O and A. So we're going to have tangent of 12 degrees is equal to the opposite, which is 500 over the adjacent, which is x. Again, x is on the denominator. So we're going to do a little switcheroo here. So x equals 500 divided by the tangent of 12. All right, in the calculator, tangent 12, we have approximately 2,352.3 feet. It's in feet, right? Yep, 500 feet. Okay, so that's how far, how many feet we need. Almost, well, it's about half a mile, isn't it? About half a mile we need a clearance of 500 feet at least in order for that airplane to take off at a 12-degree angle. All right, I kind of want to maybe hit a couple on your homework just for fun, or at least give you a path for it. Let's look at number 7. Here we have an angle, 70 degrees, and we have this side, which is opposite, so we label it opposite, and we have this, which is the hypotenuse. OH is tangent. Remember, tangent is sine. Sine is opposite hypotenuse. Sine is opposite divided by hypotenuse, which we have. So we have sine 70 degrees is equal to opposite over hypotenuse, 13 over x. Again, x is on the bottom, so we're going to switch. X equals 13 over sine 70. And then just place that in the calculator. 13 divides sine 70, and that is 13.8. Approximately 13.8. All right, so pretty easy stuff there. This one, we're looking for KL, which is this side right here. We have this angle, and this is another one of those where we need another side. So I would start with this red triangle here. Okay, you have this angle that's 51, you have the adjacent side, and you are going to look for the opposite side, and that is OA is tangent. So first, you'll do the tangent of 51 degrees is equal to the opposite, which we'll just do x, we'll make that x, over 14, the adjacent. All right, once you multiply by 14, you'll have 14 times the tangent of 51 degrees is equal to x. Figure out what that is, 14 tangent 51, and that is 17.29. And then that is your hypotenuse of the green triangle here, hypotenuse. And then we have an adjacent, and that is cosine. Cosine is adjacent divided by hypotenuse. So we'll have cosine 72 is equal to adjacent, which is our x, over hypotenuse 17.29. All right, I'm going to let you finish that. That's not done. You still have to solve for x and put that in your calculator. But I wanted to draw one of these pictures. Max built a skateboarding, we'll do 10, skateboarding ramp that is 16 inches high. So here's his ramp, and it's 16 inches high that he built. Okay, in the form of a triangle. The angle formed by the ramp and the ground, so that's this angle here, since this is the ramp, and this is the ground, is 21 degrees. What is the length of the ramp? So we want that. Okay, just make sure you get that picture right. Here we have opposite, and here the ramp is the hypotenuse. OH is sine, so sine 21 is equal to opposite, which is 16, over hypotenuse, which is x. I'm just going to set it up and let you finish it. I just want to make sure you can draw these pictures. And then here we have a ladder. Here's your building. Okay. Building. And a ladder's leaning up against the building. Okay. And it makes an angle of 75 degrees. So right here is 75 degrees with the ground. And the foot of the ladder is 6 feet from the base of the wall. Here's the base of the wall, here's the foot of the ladder. If that's 16 feet, that's where you need to write in that 16 feet. What is the length of the ladder? Okay. So that's what you're asked to find. This is your adjacent side, and this is your hypotenuse. So A and H makes cosine. Cosine is adjacent divided by hypotenuse. So cosine 75 degrees will equal your adjacent side, which is 16, over your hypotenuse, which is x. Both of those 9 and 10 will be switcheroos. So good luck with your homework. Have fun with that. You'll need to finish those problems, but I just want to make sure that you knew how to set them up correctly, and have fun.